we were on question 4. So yeah, question 4a part. So here we have split the X-train like into this. And then what was the question? Please split the data and label into training and text while the size of the test data is 20%. So 20% for the size is, so for that we have given test size equal to 0.2, and the for the random state it's 123 a whole class, so answer should be similar. So now we have to check the first 5 rows of X train, X test, Y train, Y. So for that we have to check the first 5. So it's first 5 from 0 to 5 rows and columns. X train we feed you, it's first 5. See, and for Y train, if we X test it, it's this thing. If we train the data, it will give us this, and if we test the data of Y, it will give us the data like this. Now we have to check the length of the X train and the X test if the number are 120 and 30, which is awesome. Now we have to check the length. So for the length we use len X train. So here is, so it will show 120, that is right. And for the X test it will show 30, which is also right. So we are good, yay. Next step. Now we have to convert Y train and Y test into categorical and call them one hot train labels and one hot test labels respectively. Okay, so from TensorFlow, what do you mean by TensorFlow? First of all, TensorFlow provides us a collection of workflows to develop, and you know that it helps us to train models using Python and to easily deploy, right? And we have to import the categorical, right? So Keras, the Keras library, right? It help which provides functions to perform actions on NumPy using the method to category. A NumPy, a vector which has integers that represent different categories, can be converted into a NumPy array, which will help us to categorize, right? Can be converted like a NumPy array. So we have to do like one hot respectively, right? So one hot train labels to category Y train, and for Y train we have to do an Y test, right? So it will respectively the same thing, right? It's all good. Now we have to define a sequential model. Sorry. That contains 3 dense layers. The first and second layers use 100 hidden units, ReLU activation function, and for last layer we need to use any number of outputs, right? The reason is have 3 classes. Also we have to pick an appropriate activation function for the last layer. Okay, so yeah, from Keras import models. We have to import models. What models exactly means in Keras? What import is to fetch a module as a whole. When we use from statement, you copy names from the module, right? So this will help us to copy the module names and everything. And this, yeah, so this will help us to copy the things. Okay, now for the import, like for the layers, our primary building block of Keras models, right? Each layer receives input information, do some computation, and finally output the transport information. So here we are doing the same thing, model equal to model sequential. We are adding it layer dot dense. As we have this first and second layers, we have the sequential model to contain 3 dense layers. We are adding, right? 3 dense layers, 100 activation is ReLU and input shape. It's all up to us, right? Yeah, I didn't mention. So yeah, so yeah, so when we add this, if we run this will be good. Now please compile your model using, okay, now we have to compile the model same category across temp. Okay, so what category across entropy means? It's a loss function for multi-class classification model where there are 2 or more output labels. The output label is assigned one hot category encoding value in form of zeros and ones. So that is the purpose of category cross entropy model. So we have to compile, right? An appropriate loss function and accuracy we need to find.